So these are two alternating series. What do you think makes it alternating?
They're alternating.
The fact that they're going positive, negative, positive, negative. So the alternating series test is only for series that alternate, which means it's an easy one to figure out if you should use the test, because none of the ones that we've looked at so far change sign. Okay? When you look at the series, like if it's written in sigma notation, what would make it look alternating? It would have a -1 to the n, or it would have like -1 to the n plus 1 in it. Okay? If it's got that in it, this is the test you're going to use. There's two things that have to happen for the alternating series to converge. Okay? The first one is that the limit, as you approach infinity, of an, absolute value, meaning don't use the -1, the limit has to be 0. If the limit is not 0 of the terms without the negative, it will not converge.
Wait, hold on. This is converging.
The second rule is that each term has to be less than the one before it. For all n.
For A.
That's a A. It just didn't connect.
What is this language?
This one's smaller or the next one? Wait.
The next one is smaller than the previous one. On the first one, 1, -2, 3, -4. You can look at that and tell if it converges or diverges, right? Like, look at this right here. Does that converge or diverge? Diverges, right? Okay, look at what's supposed to happen. The limit has to be 0 of the terms without the negative. Is the limit 0? No. What about an plus 1 has to be less than an? That's not true either, because 2 is bigger than 1, 3 is bigger than 2. So neither one of those conditions are met on the first one.
Also, does it matter also for the sign, it doesn't matter on the...
Right. On the second one, that's fine. On the second one, it's 1, 1/2, 1/3, 1/4. Is the limit 0? Yes. Is each term, as they go on, is each term less than the previous one?
Yes.
Yes. That's why that one converges. Okay? Both conditions have to be met. If one of them's not met, it diverges. Yes.
This may have been asked about it.
So let's say we have this one. This is geometric, right? Because the r is -1/3. We know what this one does. What does it do?
It converges.
It converges. So technically, we can use just the fact that it's a geometric series. But if you wanted to use alternating series, does the limit of 1/3 to the n, what does the limit equal?
0.
Right, because it's a geometric series and because r is 1, that limit has to be 0. So that condition is met. Write out a few terms. Let's see, the first term would start with a 1. And then I'm not worrying about the negative, I'm just writing out the terms. Is all the terms going to be less than the next one?
Yep.
So you need to say an plus 1 is less than an. Like, you need to say that the limit's 0, and you need to say that the next term is always less than the previous. So converges by alternating series test. Although you could have done that one with geometric. Questions about that one?
Well, they like give us that on the desk, like telling.
Is this one alternating series? How can I tell?
You just got the negative in or -1.
Okay, because of the -1 to the n plus 1, I know it's alternating. This one's kind of tricky, because without the negative, would it converge or diverge? If the -1 to the n plus 1 wasn't there, would that series converge or diverge? Diverge because of a p-series, right? Well, the negative 1 to the n plus 1 is there, so we're not thinking about the p-series because p-series doesn't alternate, okay? So we're trying to figure out, okay, what's the limit as n approaches infinity of 1 over n? What's the limit? 0. Top has less degree than the bottom. That condition is true. Okay, think about the terms. 1 over, you plug in a 1, that'd be 1 over 1, 1 over 2, 1 over 3. Are the terms always less as you continue to go on? So does this converge or diverge? So this one was kind of interesting because without the negatives, that's actually a diverging series, which is weird. But with the negatives, it makes it converging.
Basically, you just kind of get rid of the negative 1 and equals 1.
Wait, why does it,
Okay? Try that one by yourself. So the limit on this one as you approach infinity of 2 over 2n minus 1 is a half. So that means it diverges.
You even have to do the other test.
I don't even have to check the next condition because if one condition doesn't work, then it automatically diverges. Sometimes it's not as obvious whether you have a alternating series or not, and you might have to just plug in some numbers to figure it out. This one's kind of a strange one. Another one that I've seen that's kind of like that, where you have to plug in numbers and kind of guess and see if it is alternating or not, is one that has cosine or sine in it. We'll look at that more tomorrow, but on this one right here, you can't really tell what this is. I know that the first one is a p-series and the second one is a p-series, and both of them diverge, but you're subtracting them, so I don't know what that means. Okay? So what I'm going to do is I'm going to plug in some numbers. So I'm going to plug in 1 into both of them. So I get 4 minus 2. And I'm going to plug in 2 into both of them. So then I get 2 minus 1. Plug in 3 into both of them. And then so on. Do you think this converges or diverges? It looks like the limit is probably going to be 0, right? It looks like that limit's going to be 0, so that condition is true. What about the next term always being less than the first one?
No.
Show me one case.
2 and 2.
That doesn't work with the 2's. It has to be completely less, not equal. It also doesn't work with the 1 and the 4/3. Now, I will tell you, if you got a common denominator up there, you could create that series and make it that it equals 2 over n, which is a diverging p-series of 1. But that was just one that sometimes if you can't tell and you have to do it, like if they say use alternating series test, you might have to plug in the numbers and see.